Hey guys, welcome back to another video. In this video we're going to be going over a 4-mark inequalities question from Edexcel for the Pure Maths IGCSE past paper from January 2012. It's paper 1, question 3 for anyone interested in looking at the reference on the Edexcel website. It's 4 marks, as I said before, and yeah, the instruction is to solve this inequality. And what do they usually mean when they say solve an inequality? It means they want you to give some sort of range or some sort of inequality involving just the x term, which gives you an idea of what this actually means for x. So you can actually look at it reasonably similarly to an equation, because the same principles apply. You can do the same thing to both sides. You can flip it, but a few important rules abound, and one of the important rules is that if you're multiplying by a negative number, you must flip this sign, because you still have to remember that it's not an equal sign, it's a less than sign. For instance, if you have minus 3 is less than minus 2, you multiply by negative 1, then positive 3 is less than 2? No, it's not true. So a negative 1 multiplied by this sign is a greater than sign. But anyway, that's just a sort of quick recap on the rules for dealing with inequalities. This is a quadratic inequality, and it will require some sort of special technique to deal with. So how will we go about dealing with this? Well, what we usually do is attempt to get it in the form x plus a, x plus b is less than or greater than 0. And this is because in this case being 0, minus a is a x-intercept, and in this case being 0, minus b is an x-intercept. And once you know these x-intercepts, you can sort of give a rough sketch of the graph. So you have like minus a, minus b, and for it to be less than 0, you know that it has to be between minus a and minus b, because that's sort of the way the graph goes, right? So how would we deal with this? Well, what we can do at first is to get rid of the 6 here if we wanted to, but I'm not actually going to do that, because my suspicion here is that this quadratic expression is going to be quite easily factorizable. And we're going to do something called factoring by grouping. So what is factoring by grouping? Well, say you have this kind of quadratic expression, and it's ax plus b multiplied by cx plus d. How would we expand this? Well, if you expand this, you get acx squared plus bcx plus adx plus bd. And what factoring by grouping attempts to do is to put any sort of quadratic expression with real numbers into this kind of form, so that you can factorize out like this, back into its original 2 linear factors. So how would we go about doing this? Well, I've sort of shown you how we assemble and disassemble this sort of expanded form of a quadratic equation, or a quadratic expression. And the key thing to pay attention to is how it applies to the real numbers here. The technique you usually use is, because you have this sort of AC and BD here, if you multiply them together, they become ABCD, right? And you also have an AD here and a BC here. So when you add those up, you get AD plus BC. And even though this number and this number aren't equal to this number or this number, if you multiply them together, they're still equal to these two multiplied together. And that's the most special part of it. So if we let AD be M and BC be N, and therefore this number goes to Mn, even though finding M and N will tell us nothing directly about this, we can actually split this quadratic expression into sections made of M and N, from which it will be quite easy to factorize the linear terms out in the way that I've described here. So if this all sounds a bit abstract to you, like it's not a real technique because you haven't sort of seen it in action yet, then don't worry, because I'm going to apply it to this quadratic expression through this video. So we have our Mn, this sort of first degree term, being equal to minus 19. Or rather, this is our M plus N is equal to minus 19. And our Mn is going to be equal to the constant term multiplied by the second degree term, which is 6 times minus 7, or minus 42. And what we want to do is find integer, hopefully integer values of M and N that are easy to play with, so that we can actually factorize that quadratic expression. So how would we go about this? Well, it's immediately obvious to me what they are, but that's a thing that sort of comes with practice. And a systematic way to go about finding M and N, if you're really unsure or some kind of question's really puzzling you, is to list out all the pairs of factors of the number product Mn. So for instance, for minus 42, we can list out the factors of 42 and their sort of complementary factors that multiply into this number. So there's 1 in 42, 2 in 21, or 1 in minus 42, 2 in minus 21, 3 and minus 14, 7 and minus 6, 6 and minus 7, 14 and minus 3, 21 and minus 2, 42 and minus 1. And these are sort of possible values of M and N. And if you noticed that 2 minus 21 is minus 19, and 2 times minus 21 is minus 42, then good on ya, because this is a set of values of M and N that we can use to deal with the quadratic expression in the question. So how do we actually apply this? We're going to split up minus 19x, which is equal to m plus n times x, into its component parts, mx and nx. So minus 19x will become plus 2x minus 21x. And this may seem counterintuitive. You're making a simple expression more complicated, but for what reason? Well, the reason you're doing this is because when you write it out in full, 6x squared plus 2x minus 21x minus 7 is less than 0. You might actually notice that it's suddenly gotten so much easier to factorize, because on this side you can factor out a 2x term, so 2x times, 6x squared divided by 2x is 3x, and then 2x divided by 2x is 1, so you have 3x plus 1 here. And now, once you have this linear term, you know that this linear term is actually one of the terms in the quadratic expression when you're factoring it out. So you look for this term in the minus 21x minus 7, and coincidentally, it's there also. Because if you factor out a minus 7 from this term here, then you get minus 7 times 3x plus 1 is your minus 21x minus 7. So now you know that this is less than 0. You can factor out this entire thing. You can factor out this 3x minus 1 from the entire expression, and you'll get 3x plus 1. 3x plus 1 multiplied by 2x minus 7 is less than 0. Alright? So that's sort of the hard part to this question, that you've changed this function into a factored form from which you can finally extract the roots. So, since we have a quadratic, the safest way to go about finding the true sort of range of x values that we want, an inequality for x that we want, is to plot it on a graph. And how we do this? Well, since we know that a, the first term of the quadratic, is more than 0, it's an upward facing graph. It's a positive quadratic. And it would be helpful for us to find the x-intercepts. So how would we do this? Well, when this function, when this whole expression here is equal to 0, it's either this term, the 3x plus 1, that's equal to 0, or 2x minus 7 that's equal to 0, because 0 times anything is 0. So let's try that on each of these factors. 3x plus 1 is equal to 0, minus 1 for both sides. 3x is minus 1, or x is minus 1 over 3 when we divide both sides by 3. Or, given that 2x minus 7 is 0, 2x is equal to 7, or x is equal to 7 over 2. And these being our two roots, or x-intercepts of this function, we can actually do a little quick sketch of our graph. You don't need to sketch it at all usually, but what I find is that sketching it helps you visualize the function that you're using an inequality on. So we've got this minus 1 over 3 and a positive 7 over 2, positive quadratic going through both of those points. And the original question stated that this function, which we'll call fx, plotted on the graph there, is less than 0. So we want to find all the x for which fx is less than 0. And that's quite easy actually, because as soon as you go below 0, because it's a quadratic and these both go, this goes up infinitely and this goes up infinitely, you know that the only values of x will be between the two roots of the quadratic, because that's where it's underneath the x-axis. So, firstly, because it's a strict less than, it's not a less than or equal to, it's just a strict less than, x must be strictly greater than 1 minus 1 over 3, and x must be strictly less than 7 over 2. Or, in other words, minus 1 over 3 is less than, x is less than 7 over 2 strictly. And this would be our final answer. So that's how you would deal with this question, and I hope I've opened you to the idea of factoring by grouping, and which you could always ask your teacher, your maths teacher at school, if you're having trouble with this concept. And I hope that I've sort of cleared this question up for you if you were having problems with it. So again, thank you for watching this video. If you found it helpful, please subscribe. On Watch Me Do Math, there are always new videos every Sunday, Tuesday, and Thursday at 10 a.m. Universal Coordinated Time. That's 3 or 4 p.m. in Bangladesh, 5 p.m. in Burma, and 6 p.m. in Hong Kong. Thank you so much for watching.